Hello, it's Mr. C, and this is a short video on the use of Google Sheets to create a histogram. Now, if you don't know what a histogram is, I suggest that you talk to somebody if you think that it's a tool that's appropriate for the representation of your data. It is a very powerful tool. It's very, very common in scientific literature, and it can do a lot for your data. Again, if your data is appropriate for a histogram. And why would you use a histogram? Well, a histogram basically is a way of graphing the frequency of certain measurements of data. Now that may not make sense immediately, but I'm going to show you a couple of examples. For example, if I start with this over here, I have a column of plant height. This is the raw data. Let's say I go out into a field and I'm measuring the height of a certain species of plant. And I want to round off these height measurements to the nearest foot for whatever reason. There's a wide variety of reasons why you might be only interested in certain groupings of data. So for any plant that's near 1 foot in height, I'm going to call it 1. I'm going to round off to 2, so I'm going to round off to the nearest foot. Okay, and the bin, which I'll get to later, is going to be plants that are within that 1 foot range. Okay, so if you notice, these numbers repeat. So every time I measure a plant, I'm recording its height and I'm rounding it off and I'm putting the measurement here. So I have this long list of data, and you see 1s, 2s, 3s, 4s, and 5s in my list, and they repeat. So every new plant I measure appears to be somewhere between 1 and 5 feet in height. So to graph a histogram, I would simply take this raw data, highlight this column of data to the end, and at the top menu bar, I would click Insert Chart, and you're going to notice that Google Sheets will recognize this already as a histogram because you have this one column of data, and it will default to that. If you notice this here, it's already defaulted to histogram. And you say, well, that just looks like a column graph. And it does look like a column graph, but functionally it is different. For one thing, on the x-axis, you must have a continuous range of numerical data. Remember, in a column graph, these were categories, meaning that, if the categories were countries, you can't say that countries are a continuous list. That's a different thing. This is a continual range of data. So let's say that I didn't have any plants between 2 and 3. I would still have this zone, this what we call a bin between 2 and 3. It would just be empty, and I would have to show a continuous range. All right. What a histogram does is it allows for a lot of statistical calculations that other graphs, like a column chart, would not allow for. It also shows trends in data that you cannot show in a column chart. So now that I have this, let's go ahead and take a look at the axes here and customize our chart. So I'm going to give the chart a title, plant height, whatever you're going to call it. I actually don't think I want a legend here. I might just get rid of that. I don't think right now. I can always add it back if I want, but I don't think it's helping me right now. I'm going to go to my axes and, actually first, before we get down there, buckets. You say, well, what is a bucket? Buckets or bins are the defining characteristic of a histogram. And think about it exactly like you would a bucket or a bin. It's something that holds stuff. Each one of these groups from 1 to 2, from 2 to 3, from 3 to 4 is what we call a bin or a bucket. Into each of these bins go the number of measurements that fit in here. So any of the plant measurements that were 4 are in this bin. Okay, and there looked like there were 5 of those measurements because this line here comes up to 5. All right, between the 2 and 3, I believe that was the 2-foot plant measurements. All of those measurements go into the 2-foot bin, and that bin looks like it's 7. And it will tell you if you mouse over it, 7 items were in this bin. So the frequency of plants between the 2 and 3 foot was 7 out of the number of measurements that you took. So again, your x-axis is a continual range of data. This is numbers, for example, height, but it could be any kind of numerical data. And the y-axis is going to be the frequency of each of these measurements in these bins based on your data. Okay, so I'm going to say bucket size. It looks like it's already calculated an example bucket size of 1 foot. And I think I want that. But let's say, for example, I wanted to go 0.5. I said, well, I want each bin to be half that size. It would be very strange because your data doesn't lend itself to it. What if I went 2? You could do that. But again, it mashes everything together, but you might want to do that. You can change your bin size based on your data however you want. You might say, oh, actually, based on what I'm looking at, this histogram tells me more appropriate information than a larger number of bins. But I'm going to go back to the 1 foot bin because that's kind of already how I had my data. Horizontal axis, I'm going to say is going to be height in feet. Okay, oops, I think well, you can fix that. Actually, I think I'm going to fix that. There we go. All right, and then my vertical is going to be frequency. Okay, and that's basically how a histogram works. Let's look at another example though. Okay, I'm going to cancel this out. Over here, I have pH values. Here's another numerical data set that comes in a range. pH values go from 0 to 14. Okay, so let's say these are the pH values that I've gone out and measured in whatever experiment I'm doing. And again, it's a giant long list of raw data. So I'm going to highlight this, just like I did the one before, go up to Insert Chart, and again, because it recognizes that one column of data, it's going to say, oh yeah, histogram looks like where this guy's going. And indeed, it is right. And notice also, it looks at the data and it makes an educated guess as to the bin size, which is kind of cool. I'm thinking, oh yeah, it's looking like it's making the bins about 0.5 pH value. So anything between 2.5 and 3, those number of measurements was tossed into this bucket or bin. 3 to 3.5 was tossed in here. How many measurements were there? And so obviously we can immediately spot a trend in our data, say, oh, the 3.5 to 4 seems to be, since the value was 8, there are 8 measurements within here, that seems to be the dominant pH range there. But, as we did before, I can customize that down here at bucket size, and I could say, well, what if I went 0.2 instead of 0.5? Okay, that's interesting. You might want to do that. Okay, what if I went 0.1? Okay, you might want to do that. But it looks to me like 0.5, okay, makes a lot of sense given the kind of data that we have. And again, you change this horizontal axis is going to be pH. All right, and again, there will be some kind of frequency of those numbers of measurements. You change your chart title to pH, however you want to deal with it. Okay. All right. So that is how to use a histogram. Oops, got emails popping up. That is how to create a histogram. And again, it's a very powerful way of representing data. If you have large numbers of data measurements and you want to look for good trends in data, a histogram might be the tool for you.